In this example, we are heating some metal cans. Now the volume is 1 litre. We start at 22 degrees and the pressure is at 1 atmosphere. But we heat it, so it basically heats up, it gets to be hot. So now the temperature goes up to 150 degrees. So what is the air pressure inside now? Well, that's obviously going to increase. The equation we use is PV is equal to nRT. But we'll rearrange that to get the three variables by themselves. PV divided by T is equal to nR. And these are equal to the constant nR. So PV over T for the blue will be exactly the same as PV over T for the red, because this will be equal to the constant. Because the number of moles, N, is not changing. It's the same container with the same number of moles of gas inside. So, this PV over T before the heating is equal to PV over T after the heating. So, PV over T and this PV over T, well, they're equal to each other. However, the volume is not changing. So P over T is equal to P over T. Let's make this a little bit more numerical. We'll call this P1 over T1, which is basically the pressure and temperature before the heating, is equal to the pressure divided by the temperature after the heating. Let's define these terms. P1 is equal to the pressure before, which is 1 atmosphere. T1 is the temperature before, which is 22 degrees. But wait. It's in centigrade or Celsius. It has to be in Kelvin. So T1 is equal to 296. P2 we need to find out. T2 is the final temperature, which is 150, of course, plus 273, which is 423. So we substitute the values. For P1 over T1 is equal to P2 over T2. And we're just left with an unknown, P2. So we multiply both sides by 423, and we end up with P2 being equal to 1.43 atmospheres. So the pressure will increase if you heat it up.